Hello students, today we are covering 7.2a, finding the least common denominator in rational expressions. So that's what we will be able to do by the end of today's lesson, finding the least common denominator. We're going to warm up with a group activity, this get ready. So I'm going to have you get into groups right away and you're going to discuss these A through D and fill in your notes with that. Okay? All right, let's go over this next section that's talking about building a rational expression into an equivalent rational expression with the indicated denominator. So basically, we're trying to find equivalent expressions. And I will do every other one with you, and then the others you'll do in your groups. All right, so to get from 3 to 21, we multiply by 7. So we're going to do the same to the 2. 2 times 7 is 14. On C, we have 3 equals blank over 12. If I put a 1 in the denominator, you can see that you had to multiply the denominator by 12. So you want to multiply the numerator by 12, which gives you 36. And then we have E. How could we get from 3a to 18a squared? We would multiply by 6 and a. So 8 times 6a is 48a. And then let's do G. You can see that we had x minus 5 in the denominator, so we had to multiply by x plus 1. So 2 times x plus 1 would be 2x plus 2, or you could leave it as 2 parentheses x plus 1, which might serve you better in the future if it's already factored. So either one of those is fine for today. All right, go ahead and do B, D, F, and H in your groups. Let's take a look at I and J. It's hard to see what we multiply x plus 2 to get this x squared plus 8x plus 12. But maybe if I factor the 8x squared plus 8x plus 12, I might have a factor that's also an x plus 2. All right, factors of 12 that add up to 8 would be 2 and 6. So I set this up as 2 sets of parentheses. X times x is x squared. And 2 and 6 give us 12 when we multiply, but when we add, we get 8. All right, cool. So that means that if we multiply x plus 2 times x plus 6, we get that factored form. So then we would have to multiply the numerator by the same thing. So x minus 2 and x plus 6. So we could leave it like that, or we could distribute it. So that if we distribute it, we would get x squared, we would get 6x and minus 2x, which combine to be 4x minus 12. And that would be the numerator. All right. Why don't you take a moment and do J in your groups? Here are some steps for finding the least common denominator. The first thing that we do is we factor each denominator completely and write any integral factor as a product of primes. Use exponent notation for repeated factors. So you might have like an x times x or an x times x times x, and we'll just write that as x squared or x cubed, if that makes sense. Then the next thing that we do is we write the product of all the different factors that appear in the denominators. And the last step on each factor, use the highest power that appears on any of the factors in the denominators. So for example, in the x to the second or the x to the third, you would want to use the x to the third because it's the highest power. All right, looking at this example, we want to find what the least common denominator would be if the list that we have are the least common denominator, or is the list of denominators. So we have 24 and 30. We're going to factor each of those into their prime factorization. So 24 is 2 times 12, and 12 is 2 times 6, and 6 is 2 times 3. Okay? And then for 30, let me zoom in so you can see better. For 30, we can factor that into 2 times 15, and then 15 is 3 times 5. Those are our prime factors. Then we look at, is there anything repeated? That's still step 1. So I would write this as 2 to the third times 3. And then on 30, I would write it as 2 times 3 times 5. Then we have to write the product of all the different factors that appear, and we're going to use the highest power. So for the 2's, we're going to use 2 to the third. And then we use the 5. We do have to use the 3. Okay, so then if we multiply that out, it would be 8 times 5 is 40, times 3 is 120. So the LCD is 120 for this one. All right, try B and C in your groups. Now let's look at D. We don't have to work with the numbers on here, which actually makes this a little bit easier. So the highest power for the x's is x to the 5th. Then the highest power for the y's is y to the 2nd. And the highest power for the z's is z to the 5th. So then our least common denominator is x to the 5th, y to the 2nd, z to the 5th. Okay, let's look at E. The first thing that we have to do is factor them completely, so I'm going to factor out a 6. Then on the other one, I'm going to factor out a 9. So here we can see that x minus 5 is the same, and then we have 6 and 9. And then 6 and 9 factor further as this, and since the 3 are repeated for the 9, we're going to write that as 3 squared. All right, so the LCD, we're going to use the 3 squared, we also have to use the 2, and we also have to use the x minus 5. So that will be 3 squared times 2 times x minus 5, or 18, because 3 squared is 9 times 2 is 18, x minus 5. All right, go ahead and try F in your groups. You're going to have to factor these first. For this example, we are looking for the LCD, and then we're going to write each of the rational expressions as an equivalent rational expression so that they have the same denominator. So we're looking at 6 and 4. 6 is 2 times 3, and 4 is 2 times 2. the 2 times 2 becomes 2 squared. So we're going to need to use the 2 squared and the 3 as our LCD. 2 squared is 4, and 4 times 3 is 12. So our least common denominator is 12. Now we want to write each of these expressions with a 12 in the denominator. So 5/6 to become 12, we multiply by 2, so that becomes 12. We multiply the 5 by 2, and it becomes 10. Use a different color for this arrow. Should actually be like this. The 1/4, we're going to multiply by 3 to get 12. And then we're going to multiply the 1 times 3, which gives us 3. Now these are not simplified, because if we simplified them, we would get what we had originally, but we're preparing to be able to add and subtract rational expressions. So we can't do that unless we have a common denominator. Let's look at B. The highest exponent for x's is x to the third, and the highest exponent for the y's is y squared. So we know that we need that as our LCD. We also have 6, 8, and 4. Okay, so 6 is 2 times 3. 8 is 2 times 2 times 2. And 4 is 2 times 2. So we're going to use the one with the most, which is this 8 has 2 to the third, and we have 3 as well. So 8 times 3 is 24. Our LCD is 24, and then don't forget your variables as such. Okay, then we need to write each one of those with the same denominator, 24 x to the third y squared, for each of these 3 expressions, rational expressions. 24 x to the third y to the second on each one. So how do we get the 6 to become 24? We multiply by 4. So we have to multiply the 5 by 4. And then how do we get the x squared to become x cubed? We have to multiply by x. And there was no y squared, so we also have to multiply by y squared. So on the top, 5 times 4 is 20, and then we have xy squared. For the 8 to become 24, we multiply by 3. The x cubed is already there, so we don't need anything. The y to become y squared is y. So then in the numerator, we have 3y. Then the last one, to get 4 to become 24, we have to multiply by 6. And then we have to multiply by an x cubed because there was no x, and the y squared is taken care of, times 6, which is 18. X to the third. And on C, we have to factor first, right? So factors of 16 that give us negative 8. I think that's negative 4. And this is actually a trinomial, so x minus 4 squared. And then factors of 12 that give us negative 7 are negative 3 and negative 4. Well, that's cool. We have a negative 4 that happens twice. Okay, so for our least common denominator, we have to use this one because it's squared. And then we also have to have the x minus 3 because the other one does. Okay, so we are going to multiply. All right, just a second. So the denominator for each one, I'm running out of space, is going to be x minus 4 squared and x minus 3. So how would we get the first one with the 9 in the numerator and the x minus 4 squared? We also have to multiply that by x minus 3. So I'm going to multiply this 9 by x minus 3. So 9 parentheses x minus 3, because that's what the denominator was missing on that one. Now on my second one, the 5, the denominator was x minus 3 times x minus 4, but it's missing an x minus 4. So I'm going to multiply by an x minus 4. And that becomes 5x minus 4. Now you have common denominators. Let's try D in our groups. And then I will let you write your summary on your own when you're reviewing your notes.